Okay, well, where we left off, I was trying to work out what was going on. I thought it might have been the master-slave issue. So it turns out it was. The difference between, if we have a look, let me see if I can zoom in a little bit. You'll see a part number here, and that part number, or the model version, provides some additional information about how the drive actually works. And so how they actually work is they have a pin that's part of this connector here that controls whether it is master or slave. And what you do when you put it in a machine is, like in this particular case here with this item here, we can see, let me see if I just move that back out of the road a bit. Can we zoom right in so that we can get some macro lensing in here? Should resolve. Now let me get my little pointy stick. What we're looking at here is the power's coming in on here, and so we can see that the ground power comes in and it follows this trace over here, and then it joins towards the end of this board here. Now if we go and take a look at what's happening over here, you can see that little via pops through, and what we're getting is a connection to a pin over here. And then if we look at what's happening here, is that's coming back through, here and then coming over along into this connector here, and this pin right here, we're dragging, you can see that pin there, we're setting a low on that pin. Now depending upon which part you actually get in these slimline drives, whether it's an A30 or one of the other, because tens of them as far as I can tell just from TAC, will determine whether that pin being taken low says that the drive is a master or a slave. So they have, in this case, this one was set to be low as a slave. This guy assumes that low means that it wants to be master. No great problem, you say. Simply get a cable and plug it into the secondary port. Awesome idea, would love to do that. Unfortunately, it is Sunday. No PC shop, well, it was Saturday night when I discovered this, but it's Sunday now. No PC shop carries IDE cables anymore. There's none on Amazon that I can order for same-day delivery. And so I want to finish the video and get us to the point of where we're booting the HP Basic card. So to do that, I went out and, let me just stand this up a little bit more so you can see it. I went out and I bought just an external SATA drive, and I've got a rat's nest of stuff on the back here. What I'll do is I'll show you an image of it and then we'll talk through the image.
Okay, so here we see the rat's nest. I decided to do it this way rather than show an image because I wanted to make sure you could see the mouse pointer and use that as a highlighter. What we see here is the rat's nest of stuff, and you can see there's the IDE cable that is coming out, and this is the cable that's going to the main drive, and that main drive is this guy down here. This is the compact flash to IDE adapter. This will be replaced by something that has a bracket on it and can fit in the side of the machine, but for right now this makes it possible for us to boot that. The next thing that you see is this cable here is the floppy drive cable. It's coming down here to that replaced floppy drive that we have. And part of this assembly here is where the CD-ROM drive would be. Now, we were talking about how I couldn't get an IDE cable and the master slaves were off. So what I'm using is this thing here. This is a SATA to IDE adapter. It's actually a pretty cool little adapter. It's powered by just a 4-pin mini Molex connector, and then it has a SATA connector comes out and goes to drive. And you can also do this in two ways. You can go from the computer, so you can see here, to drive, where I have it plugged into the IDE port, and then that's connecting to the drive, and so it's connecting a SATA drive to an IDE port. And the other way around is you can put this in a drive. So if I had an IDE disk, I can put this in the drive and have that cable come out to the computer, and so it's enabled to handle the data going in both directions. So that's sort of what I have hanging off the back that will enable us to at least test that I can install and work with the compact flash card, and the two things are correct.
Okay, so I've got my Win98 stuff here. I don't know what I did with my real disk, but I've got a copy. That's some of my original hologrammatic Windows XP disks here. So we'll put Win98 on one of these disks, and then we'll put Windows XP on the other. So let's start with, let me just set this up here. Let me start with a Windows 98 one. And then we'll call this WinXP. Okay, give them a chance to dry off. Okay, so let's close that nice little case like this thing. Let's drop this guy into the drive. It's a little harder to do than I expected. The big slide is on the left. There we go. Okay. So, we should be all ready. Let's turn it on. And we'll see if we'll be able to jump into the BIOS and then do some settings. Okay, nice. Okay. So now we're up and running. Let's go into here. So IDE auto detection. Yes, we're going to go with 2. I'm going to skip this guy. And then okay, so now up in here, this guy, I'm going to just set to none. And I think secondary master should do it. So here we can see total memory is 524, 288K. Okay, so now let's go and save that. And let's reboot. Okay, skip the memory test. And secondary IDE master. All right, let's go back in because I did want to show you the other change that I had to make. Okay, so the other change that I had to make was in here, because this is registered or buffered RAM with ECC, and that's why I turned on the ECC mode.
and set the cache latency to 2 because it suggested that. So overall, that was pretty much it. And then everything else is it should just be working. So let's exit without saving. Okay, so now we're just going to boot our Win98 boot disk. We'll start the Win98 setup, and TAC drive is detected, and then we'll be able to go in and tell it to use all of the space on the drive and all the things. So rather than buggerizing around and waiting for that to complete and recording it, I'm just going to come back when we're all done, and then we'll see what the result is. Okay, so we're now back with the software installed and drivers and printing and everything. So what I've got is just over on the side here, you can see I have a GPIB cable plugged into the National Instruments card. And so what we're going to go do is we're going to run the Measurement Explorer. Now, the challenge with this is that device enumeration, instrument enumeration will fail because there are devices on the, I have let me try again. Instrument enumeration will fail because I have GPIB extenders on the network. Now what these extenders do is they actually make the system look like there is 32 or 31 odd devices connected, because it's going to extend across a coax cable. And so what I use that for is that I have my 3 rack cabinets here. I have an extender in each of the rack cabinets, and that way I only have to run a little piece of coax between each rack cabinet instead of trying to run a long GPIB cable. Anyway, what we can do to test that this is going to work is we can actually just run the interactive control. Now I'm going to go do that. So let's take a look at this a little closer. Now the interactive control is running, so the first thing that I want to do is, when I have this connected to my 3325B signal generator. So let's do a IB dev, and so the board index is going to be 0, the address of the device is 10, there isn't a secondary address, so we'll make that 0, let's give it 13 as the timeout, Sure. And then make that 0. That seems to be reasonable there. So now that I've got that, what I can do is an IB clear. So, okay, so the device is now being cleared. So I can do an IB write, and I can send it IDN question mark. So that's going to ask it to give us the ID on the unit. And so we're going to do that. And now the next command that we need to give it is a IBRD. And let's just say 50 IBs. I don't know how long the string is. And there we can see Hewlett Packard 3325B and some other data. So that's nice. So let's turn this off. Okay. So now we're all done. So what I've just shown is that the National Instruments board is working. So let's shut this down and let's go run the HP Basic software. So now to do that, I'm going to take this control out of here. I'm going to drop it on the top one, and then we will come in here. And now it's not a Windows app, it's a DOS app. Now remember, how it works is basically taking over the guts of the machine and running everything on that 68K coprocessor. So I don't believe that it works very well with Windows. So I just have it going into DOS mode here. I have to do a little bit more analysis of that to see if it's possible to run it under Windows. I'd like to run it under Windows because then I can actually extend the printer port to the IP address directly in under it. Anyway, let's double click on this. Oh, and here you can see that let me see, the coprocessor was already loaded. So what I have here is okay, so what I have here is a little shortcut with a PIF file, program information file. Anyway, that file, because I don't believe the 82324A and the software, because remember, basically what it's doing is it's running a 68K processor, a 68K computer, and then taking over the PC as a backplane to do things like display and so on. And I don't think that is conducive to running in a virtualized environment, or in the environment where Windows is also trying to do that at the processor level as well. So what we'll do is we'll just run this in MS-DOS mode. And here we go. So the card is working. We're talking to it. You can see the information here, and this is basically set up, and it should be the same as if you were using BASIC 5.1 for on a system, a Series 300 or 200 machine. So let's take a look. Is anything actually listed there? No. All right, so let's clear that. Let's write ourselves a little program. So the first thing I want to do is $8 bracket, let's say 100. I think that's right. Okay, so edit. Okay. Now, I'm going to do an assign. And so we'll call it at SG. And I'm going to give it 710. Now, what this is doing is basically saying that I can use the at SG value instead of 710. Oh, sorry, semicolon. Oh, no. Yeah, so assign SG to 710. There we go. So now I can do output at SG, semicolon, and now that same IDN question mark value, I can do an enter at SG A, and then we can do a print A, and we'll do an end. And now if I hit F3, that corresponds to run on the bottom line there. You can see that we've gone off and we've hit the 3325 and gotten some information about it. So overall, I now have the device booting to a compact flash card. I have the Measurement Coprocessor working. We have all of the stuff done. I'm just going to go and close up the back of it, put the handle back on, and then we'll start playing around further with using it. But I think this purchase has been great because this gives me now a DOS-based, XP-based machine with the coprocessor card in it to run HPUX software. It gives me the National Instruments card to run DOS and so on software in there. So, and if it worst came to worst, I had to run a specific HP app, I have a HP ISA card. I can swap out the coprocessors for that. Overall, I think that's pretty cool. Anyway, if you like this video, it's going to be a bit rambling, but if you like it, give it a thumbs up and take a look at the rest of the videos. And I'll catch you back in the comments, hopefully. Anyway, catch you later. Bye.